Okay, so thanks. So thanks for asking me to talk. I mean, I think a lot of what I'm going to say, I think most of you already know, and perhaps a warning just up front. I don't actually have any solutions to most of these problems, but there are probably better ways of doing things. I mean, some acknowledgements first. So what I'm going to show you comes from a variety of projects done in slightly different ways, and just acknowledge the people named here, but also other people involved in these projects. And so broadly speaking, I'm going to talk about kind of measuring multiple long-term conditions, and just a note on terminology. So MLTC is what NIHR would wish us to call this. But most of what I'm going to show you is studies where it's been called multimorbidity. And so I'm going to, if I'm talking about an old study, I'm going to say multimorbidity, but otherwise I'm going to try and say multiple long-term conditions. And critical to this is, what you're measuring has to be suitable for your purpose, which is why I don't think there's any real answers. But the exemplar I'm going to use is how do you measure the prevalence of multiple long-term conditions? And that's as simple a use case as it gets. So we've done some HDR UK funded work about so systematic review, what have other studies done, and then a Delphi study. How should you measure according to the wisdom of the crowd? Some other work which comes out of having to try and do this kind of thing in UK Biobank, GP data, and then some, I'm going to show you some data about measuring prevalence under different assumptions in CPRD. So what do you have to decide when you're wanting to research multimorbidity? And you've got to be clear what your purpose is. And that's easy to say, but actually it's not, it should be clear, but actually it's not always, in my experience, it's clear. It's easy not to be clear, I suppose would be the way of saying it. And maybe that's just me, but it may well be others too. What do you mean by multiple long-term conditions? So kind of what's your underlying definition of the problem? What kind of measure do you want? And so, there's debate in the literature and elsewhere about, do you want a simple count? Do you want a weighted measure? Do you want something else? And then practical things. So, I mean, which conditions are you going to include, and how are you going to measure each of those conditions or identify each of those conditions in data? And I'm not going to talk so much about the early bits because, of course, your purpose is unique to yourself. And really, just to warn you, this is many problems, few specific answers. So what is multimorbidity, or what are multiple long-term conditions? So these are two definitions of multimorbidity. The top one is the NICE definition, comes from the NICE multimorbidity guideline. And the bottom one is the Academy of Medical Sciences one, which is probably the one that is most commonly cited. And they have similarities. So, they both say 2 or more. They both have, a sense of time, long-term health conditions, chronic conditions. The NICE one kind of covers more ground. So, it talks about frailty or chronic pain. It talks about sensory impairment. Whereas the AMS one is rather more disease-focused, by implication at least. And the AMS one specifically includes infectious diseases because it was an international definition. And for example, our colleagues from South Africa were very keen to include HIV, hepatitis C. And we had a lot of debate about tuberculosis, which is long duration, but it's not necessarily quite so long duration. So, you have to have a base definition in your head, and you ought to choose one. You should cite it, I think, in the papers you're writing, and then explain how you map to it or where you diverge from it. So in our systematic reviews, so this is work done by the person who did all the work was Iris Ho, who was the PDRA. So it's a review of 566 studies of multimorbidity. That's almost certainly not all studies of multimorbidity, but it's unlikely that adding more would change the conclusions. So a third of them don't explicitly what they mean by it. They don't define it, but implicitly they usually mean 2+ conditions. 13% don't say which conditions they're including. And they include a very wide range, so 2 to 285 conditions. But the median is 17, which isn't that many. And half of studies have between 11 and 23 conditions included, which isn't that many, really, when you think about it. And if you then look at kind of, conditions from which systems are most commonly included, then they almost all have some CVD conditions, some metabolic endocrine condition, respiratory, musculoskeletal, and then about 3/4 include a mental health condition, or put another way, 1/4 have no mental health at all. But when you get down to individual condition level, there's only 8 conditions included by more than half of studies. And that's quite remarkable. And no mental health condition is included by more than half of studies. So the two, if you look on the right, in the purple, the two most commonly included mental health conditions are depression and dementia, but neither of them is included by more than half of study. So there's an enormous variation in what people are including, and that makes any comparison really, really difficult. I mean, how should you choose what to include is kind of up to you, and this partly comes down to, it's similar to the discussion about, well, should you weight measures? Well, how would you decide that a condition is important enough to include? What weight would you put on it? And this is from the same paper, and what it's showing is on the left, the global age standardized disability adjusted life year. So that's disease burden as measured by DALYs. And on the right, percentage of studies that include these conditions. And so, I mean, there is some relationship. There's no malnutrition in multimorbidity, but then multimorbidity is largely done in high-income countries. Malnutrition is primarily a problem in low-income countries. And if you look down at the bottom, you see multiple sclerosis is included, fairly often, but doesn't really contribute to global DALYs. But of course, it might be locally important. So there's a lot more multiple sclerosis in the UK, and particularly in Scotland, compared to countries nearer the equator. So you do need to be sensitive to local stuff. If you looked at mortality, you would get a different kind of pattern. If you looked at quality of life, you would get a different pattern potentially. So just thinking about prevalence, if you look at within that set of 566 studies, a number of them, about 200 of them, report prevalence of multimorbidity. And so this is a study level view. And what it's showing is, so each dot is a study, bigger dots are bigger studies. It's showing the proportion of people reported as having multimorbidity, defined as 2 or more conditions in each study. So it's the prevalence of multimorbidity defined as 2 or more conditions. And this is all study level, remember, if you look at study level, then the mean age in the study makes quite a big difference to the reported prevalence, as you might expect. And then the number of conditions included also makes quite a big difference. But of course, I mean, these are 2 are related. Studies in children tend to include fewer numbers of conditions, for example. But you can get any number between 0 and 100%. And so what does prevalence mean? How would you compare it? Well, you can't compare it without some kind of standardization of number of conditions, and you kind of need to know age sex standardized rates, or you need to know age sex stratified rates if you want to compare studies. So so that was the first bit. So the conclusion of the systematic review is it's all a bit of a mess. And then there was a second element to this, which is the Delphi consensus study, attempting to see, well, what can we, is the consensus on how we should approach this. And so the Delphi was a 3-round Delphi study. There's 150 professional participants, there's 25 patient public participants, and they're run as separate panels. There's a pre-specified meaning of what consensus is, which is that more than 70% of participants say something. And we treat the professional and public panels as separate. So if they both agree, that's fine. If they disagree, then we need to we can show that explicitly. And there's loads of questions in this Delphi. It was hard work for the participants. I'm only going to show you a few. So what's the definition of multimorbidity? When would you choose a simple count versus a weighted measure? Was something that came up in the prior work. What kinds of condition would you include in measures, and which conditions should you include in measures? So in terms of definitions, I mean, there was consensus in both panels that multimorbidity is 2 or more long-term conditions. There was consensus that complex multimorbidity is a useful idea. So if you say 2 or more conditions, it's really common. Does it always matter? There are combinations that don't matter. And so people proposed, complex multimorbidities. That might be 3 or more conditions. It might be 3 or more conditions from 3 or more body systems. Some people say 5 or more conditions. So we asked them about all of the definitions that we could find, and there's no consensus about what complex multimorbidity should be. we asked them for these 5 purposes. Is a simple count or a weighted measure preferred, or is it acceptable? And so none of them come out as clearly preferred. But if you look at the combination of preferred or acceptable, then which measures win? And so simple counts win for estimating prevalence, which is pretty obvious when you think about it. Win in terms of counting disease clusters. In other words, that conditions, if you're clustering diseases, should be weighted equally is the implication. I mean, when they meant that, it's a slightly different question. Exploring trajectories of multimorbidity, and weighted measures are better for severity, risk adjustment, or outcome prediction, which I think is kind of what we'd expect. But it's not the case that one measure is clearly superior. One type of measure is clearly superior for all types of purposes. So which conditions should you include? So we asked them to rate each condition on a scale that went from always include, usually include unless a good reason to exclude, neutral, usually exclude unless a good reason to include, and then always exclude. But it's all the scoring is in the first 3 categories. It's very unusual anyone says, oh, you definitely should not include that. And so what you get is a list of 24 conditions of always include, and then another 30, I forget how many. There's 24 in the first and 34 in the second, I think, to usually include unless a good reason to exclude. And so you might think, oh, that's great. That tells me what I should do. But does it? Well, probably not. So just an example, hypertension is usually included unless a good reason to exclude, but it's a bit cultural whether hypertension is a condition or not. So we tend to act, in the UK, we tend to act as if hypertension is a condition, a disease, and in Spain they say it's a risk factor. There's no way that you would include it. And we say, oh no, hypertension is in, but obesity and hypercholesterolemia are out because they really are risk factors. And so there's no clear boundary between conditions and risk factors, and should risk factors be in or not. And actually, it depends on where you work and what assumptions you have as to whether you might include that. There's all sorts of issues about time. And so, you've got a read code for asthma or epilepsy or VTE or endometrial, or TB, but is that in or out? And these are time-based issues, and time is really important. So, what do we mean by chronic or long-term? And so in the Delphi study, there was professional consensus that long-term means 6 or more months. In the public panel, they said it was 12 or more months. 6 months wasn't long enough. And, is venous thromboembolic disease really a chronic condition? I mean, it made it through the Delphi, but is it really? And so, of course, it can be, and then sometimes it's not. What should you do about it? Well, I don't know really, to be honest. You get long-term conditions, but which are only present in some parts of the life course. And so endometriosis would be an example, which is that with menopause, you might have the consequences of endometriosis, but you can't have endometriosis anymore. Probably the bigger problem is, well, long-term but commonly remitting. And so, asthma and epilepsy, common in childhood, often go away. Eczema the same. Depression tends to remit and relapse, but it doesn't relapse in everyone. And so, are you interested in active conditions? So are you going to qualify this with prescribing or recent coding? So that's currently treated as using prescribing, say you've got a code and treatment for asthma. Complicated, because you might be being treated for your COPD, which happens to be the same as your treatment for asthma, and it's not asthma, it's COPD. And then cancer is often qualified in terms of, in literature, in terms of, a cancer in the last 5 years as opposed to a cancer ever. And people debate this. So, some psychiatrists would argue depression is a chronic illness. It just comes and goes a bit, but it's always there. Don't know that's true for primary care depression, but that's probably true for, psychiatry seen depression. Cancer, the idea of cancer survivorship says it's with you forever. Well, it is, but are you going to count a childhood cancer in someone aged 85 years old? Well, don't know. And then if you look, many of us are going to be using Valerie Kwan, caliber code sets. But, can you really do all of her conditions? So, for example, childhood asthma. But if you're 85, there's no way your childhood asthma is recorded in electronic data because there wasn't any electronic data when you were a child. So are you really comparing, are you comparing like for like in different ages? So time's really important, and how you handle it, I think, there's a number of rational ways of handling time, but there isn't a clearly correct way. It will depend on what your purpose is. Okay, so the other Delphi study issues, I mean, there's some stuff in here which is just really rare. Addison's disease is very important for those who have it, but it's pretty rare. There's stuff in here which is really hard to define. Chronic Lyme disease, post-acute COVID. I mean, yeah. So it might be in the list, but Addison's disease is easy to measure, but extremely rare. The other ones are common. Well, no, chronic musculoskeletal problems due to injury is common, but hard to define. The other two are chronic Lyme's really, well, who knows? It's argued about what chronic Lyme disease is, but it's certainly hard to define. Post-acute COVID appears to be common, but we don't really have a case definition of it, so it's hard to include. And then the thing that really gets me, so it's the wisdom of crowds, and as a researcher, my job is to report the wisdom of the crowd. That's how Delphi studies work. But as an individual, I can, of course, think that the crowd is an idiot. And so depression is not in the always include list, which personally I think is mad. I mean, it just didn't make it. It was 69.5% said it should be always include, but you draw the line and you live by the pre-specified nature of the study. But you could also argue, and actually the patients and the public were more down on mental health being included than the professional. And so to some extent, the Delphi reproduces the stereotypes that mean that mental health is not included in multimorbidity measures, because it's a societal perception that these things don't really matter, they're less important. But they do matter, they are important. So that's me speaking as an individual, not reporting a Delphi study. Okay, so what should you choose? I mean, you can go to recommended lists, and I think they're a good place to start. If you're going to use this list, and it's not yet published, paper is submitted but not accepted. If you're going to use, I mean, I'm very happy to share the list with people who are doing work now, but not in a public way. If you're going to use this kind of list, I mean, they're kind of useful thought experiments is probably what I'd say. And there's a logic to saying, actually, if you can measure all this stuff, just include it all. It will improve comparability, but then you need to tailor it for your own context. Okay, so let's say you've now chosen which conditions you want to include. Now you have to define them. And as we all know, the problem is that all the coding systems are all a complete mess because they're not hierarchical. And they're not hierarchical for the very good reason that disease is really, really complicated. And so we all end up using a code list, and the code list typically draws codes from different chapters or sections of the coding hierarchy. And historically, of course, everyone kept all these code lists highly secret because they took so long to make that you didn't want others to benefit from the work you'd done, and you wanted to be able to reproduce them yourself. But in the modern world, these are increasingly published, and I mean, probably the single place to go, and indeed the place that you should be submitting your code list is the HDR UK phenotype gateway. And I've guessed that many of us who are using GP data are going to be using some modification of Valerie Kwan's lists or caliber definitions. And you can find her definitions either in the HDR Health Gateway, or there's a GitHub site linked from that paper. So most of what's available on the HDR Gateway, HDR UK Gateway, though, is it's kind of derived from people using CPRD Gold, and so typically it's read 2 and ICD-10. But of course, you may have clinical terms version 3, read 3 data. And in UK Biobank, that's what we were faced with. We've got a mix of read 2 and read 3 data. You may also have EMIS codes. So if you're using EMIS data, so CPRD Aurum, EMIS also includes codes which are not read, although they can look like read. And of course, we're all moving towards the glorious future that is SNOMED CT, which is just a way of saying you've now got even more codes to categorize. So every time anyone improves a coding system, they add more codes. What then happens? So you're now trying to choose your condition. I mean, I've said you've already chosen your conditions as a codeless problem, but what then happens is that you realize the problem is that chronic conditions are fractal. So you can keep subdividing them, and that's why code sets are so complicated. So the HDR UK the Delphi says include solid organ cancer, but are you going to go for solid organ cancer as a single category? Or are you going to go for individual cancers? And just some examples from Valerie Kwan's work and Caliber. So at individual condition level, she has, or they have, stable angina, unstable angina, myocardial infarction, and coronary heart disease not otherwise specified. So is that 4 conditions or is that 1 condition? And the answer probably is, well, it kind of depends. And similarly, if you look at liver disease, you get chronic viral hepatitis, alcoholic liver disease, autoimmune liver disease, liver failure, cirrhosis, portal hypertension, esophageal varices. So is that 1 condition or is that more than 1? And it kind of depends because, chronic viral hepatitis with cirrhosis, portal hypertension, and esophageal varices is different from chronic viral hepatitis without any of those things. But when you're counting, are you going to treat this as chronic liver disease or are you going to treat it as separate? And if you treat it separate and you're interested in prevalence, how do you avoid double counting? Well, chronic viral hepatitis, cirrhosis, portal hypertension, and esophageal varices is 4 conditions, but it's not. It's actually 1 condition in this person. And so there's no correct answer here, but you have to make choices about how much you're going to lump stuff together and how much you can split it apart. And if you split it, are you going to allow overlap or are you going to make them mutually exclusive? So if you look at the coronary heart disease example, you might say, well, for my purposes, what matters is that you have coronary heart disease with unstable angina or myocardial infarction, or you've got coronary heart disease without unstable angina or myocardial infarction. So these are now 2 mutually exclusive categories, rather than having people who are actually in both categories, but it's the same disease in some sense. And so if you're measuring prevalence, I mean, it kind of pushes you towards higher level aggregation to avoid double counting. But if you want to predict outcomes, actually, you might want to push to lower levels of aggregation. You want to split, and you want to make them mutually exclusive. So you're effectively defining conditions not just as present, but also as complicated or more severe in some way. And it kind of depends. And so every study I do, I find myself making different choices and therefore being inconsistent. But that's because you've got to be true to the purpose. Okay, so in UK Biobank, so we have an MRC and NIHR funded study looking at depression and physical disease accrual. And we started and so half of UK Biobank, you get GP data as well. And so we start with Valerie Kwan's code lists. We then select chronic conditions from those code lists because they're not all chronic. And then we kind of decide how much we're going to lump or split them. And then we're faced with the problem that all of her code lists are read version 2, but most of our data is read version 3. So now we need to map from one to the other. And we kind of do that with a mixture of mapping and then looking at published code lists. And so Open Safely, for example, have got a bunch of published code lists in CTV3. And then some free text searching to throw up other potential codes, which we don't identify this way. And then a clinician or 2 clinicians go through the lists and say, yes, this code means whatever it is we're trying to measure. And so one of the consequences of that is you then identify discrepancies in read 2 because we're rejecting codes in read 3, which are in read 2. And so visual impairment would be an example. And so now we go back and start amending the code lists in read version 2. So why do we do that? Well, we were kind of interested in blindness, but a lot of what's in that particular code list is visual impairment. And so if you're blind in your right eye, are you blind? Well, we didn't think you were. You are blind in your right eye, but you're not blind in the functional sense of the word. You've got loss of vision. What does that mean? I mean, does that mean you've totally lost your vision or that you're just a bit short-sighted? I don't know. I mean, I'm getting short-sighted. I'm losing my vision, but am I blind? Not really. So you get non-specific codes. You can't get impaired vision due to diabetic retinopathy. I mean, is that severe enough to matter? And then that draws you into the existential problem: is blindness a condition, or is the cause of the blindness the condition? The blindness is merely a consequence. And if you read the NICE definition of multimorbidity, blindness is a condition. If you read the Academy of Medical Sciences one, the implication is the cause is what matters. Diabetic retinopathy without functional visual impairment, yeah. So I mean, it's just really complicated. You get problems of synonyms. So for those of you not familiar with READ is a 5-digit coding system, but it's actually 7 digits, where the last 2 digits define different ways of saying the same thing in English, except that they're not always the same. And actually, depending on your data provider, you don't always have the 2-digit extension. So in Biobank, you just get 5 digits for most of the data, and they don't give you the term. That's the read code description. So you can't tell. And if you look at code lists, they often specify the 7 digits because not all of the synonyms are included. And so as an example, registered partially sighted and registered partially blind are not quite the same thing, although blind registration is legally controlled. And so I'd be willing to say they are the same thing in this case. Registered sight impaired is not a blind registration category, so I don't quite know what it means. It probably means blind registration, but hard to know. You also get lots of codes like this, so blind rehabilitation, referral to vision impairment, multidisciplinary team. Does that mean you're blind? Well, it's a bit hard to know what it means. And the process codes, I think, are often dubious. And so, and you end up you have to make lots of decisions. So the reason we use code lists is to avoid making these decisions. But unless you look at the code list, you don't know if you agree with those decisions. And so we all need code lists to suit our purpose, but you can't assume that the off-the-shelf ones do. But we really want to use off-the-shelf because the cost of making a new code list is very, very high in terms of time, resource, and delay. So it's all, it's problematic. Okay, so you've gone through all this effort to make code lists, and so what we have now is these are the conditions that we include, and they're sorted. And the top one is the category with the most codes. This is read version 3, so solid organ cancer has got more than 900 codes. All the way down to cystic fibrosis, easy peasy, there's only 2 codes. And this is then saying, okay, do you really need all those codes? If you just use the pink codes, you get 90% of the cases. If you go to green, you get 95%. If you go to blue, you get 99%. And then the purple is the other codes that get you the last 1%, which is most of the codes for many conditions. It's a bit more complicated. So this is the same data, but it's now shown by percentage. And what you'll see is it's got a ragged edge because the white space above the top of the ragged edge is the codes that are never used in 250,000 people over a 10-year period. And often they're the codes you agonize about. They're the ones where you argue, is that really Addison's disease? Well, actually, the ones you argue about turn out to be ones that no one ever uses because no one actually understands what they are. So do we really need these hyper elaborate code lists? And actually, most sensible code lists that any of us could come up with quite quickly are likely to get you 95% of the patients. And so I think there's also a risk we spend too much time agonizing over the margins of this. And one thing I would say, if you're ever going to do this, choosing codes, you want to know how often they're used, because the ones that give you the most headache turn out never to be used, and therefore it doesn't matter what you decide. Okay, so another way of looking at the same data. So this is 4 conditions: so bipolar disorder at the top, bronchiectasis, cardiomyopathy, and solid organ malignancies. And what it's showing is how many people would you identify by including 1, 2, 3, 4, 5 codes, etc., etc. And we only go up to 20. And so for most conditions, if you're including the 20 most common used codes, you will have all the patients pretty much. You don't gain much by adding more. Solid organ malignancies is an exception, but that, of course, is because it's not one condition, it's loads of conditions. And if you just picked the 5 commonest codes for each individual cancer, you would probably see that you got almost all of it. Do code lists matter? Of course code lists matter, but I think the way we do them is all a bit haphazard. And in fact, the things that give us all the pain and the grief and the arguing, and you need 3 people to reach consensus, probably don't make that much difference, actually. And if we could do this bit better, we would all save ourselves enormous amounts of grief. But I don't think we're quite there yet. Okay, so the other thing that happens, so we've now got read version 2 conditions defined, read version 3 conditions defined in different practices. And you can now look at the prevalence of those conditions in the 2 codes in practices using the 2 different types of computer system, which then generates read 3 or read 2 codes. And what you see is that actually read 3, you typically get higher prevalence of disease than you do in read 2. And that's a bit hard to explain. So this isn't age sex standardized, but I mean they're not hugely different. And so we have more work in this to do to understand it. But if you're looking at a read 3 data set, you're likely to find more disease than if you look at a read 2 data set. And why should that be? Well, so this is by year, and it's just counting the median number of codes per person per year, where pink is read 2 and green is read 3. And so if you're in a practice using read 3, they record more codes than practices using read 2. And if you record more codes, you find more disease. Is the prevalence of disease really different? Probably not. And this is consistent. We know, for example, that the amount of money you earn under the Quality and Outcomes Framework, which was 20 to 25% of GP income, varies by the computer system you use, because some systems make it easier to do stuff than others. And if something's easier to do, you do it more often. So, where does this take you? I mean, the context matters. We kind of just assume, oh, it's all GP data, it's all the same. Actually, it's not, because the type of electronic record, the coding system being used, the code browser being used. So EMIS read code browsers are much better than Vision. The Vision one I still don't really understand. And so, boy, I know read codes better than most people, and I still can't find the codes I want. And then just system requirements. Some systems make some things easier to code than others. The system design matters. We also know that payment system matters. So if you're comparing English and Scottish data, so English HES data, Scottish SMR01 data, in SMR01 you can record 7 ICD-10 codes, which I think was true in HES in the past, but you can now record 18, I believe, and that's to do with payment systems. And so your data will be much richer in England, but is it really any different? Well, probably not. There's even more international variation. If you're in a fee-for-service system, you record loads more codes than if you're in a kind of NHS single-payer system. And I suppose one thing this makes me reflect, what's the point of ludicrously elaborate coding systems? So certainly in primary care, no one uses them. So we don't get any value out of having 350 ways of recording every single type of leukemia that ever existed. And then secondary users also don't get any point out of them, because you just have to lump it all together, because we don't use the elaborated codes. We use non-specific codes because they're the ones we find. And actually, in my own case, I would often add a bit of free text to a code. So I'd use a high-level code, and then I'd say what I really meant in the free text, because I cannot find the code that I know exists with the browser available to me. And I say, never choose a code list without knowing how often the codes are used. Go to the data first. Just find out which the commonly used codes are. They're the ones that you really need to classify. Okay, so I just need to keep an eye on the time. Right, so okay, let's say you've got your code lists, you're happy with them, you know your conditions. Does it matter which conditions you include? And so this is, we're all looking at prevalence. And so this, using CPRD gold data, it starts with Quan code lists. We've got 81 conditions, which is a mix of selection for chronicity and other things, and then our decisions about what we lump together or don't. And we're going to look at the prevalence of 2 or more conditions for a different number of conditions included in the measure. And then I'll quickly show you something like complex multimorbidity. This is all preliminary data, so it's almost certainly not true, but it is, the shape of it is unlikely to change. Okay, so you want to measure prevalence, and you can choose to have 2 conditions, 4 conditions, all the way up to 81. And so the blue line is what happens if you always choose the most common conditions. And the red line is what happens if you always choose the least common conditions. And the true prevalence, well, depending if you made a different choice, the prevalence you observe will be somewhere between those 2 lines. And this looks so much like a liver that you can call it a liver plot, if you like, for those of you who know what livers look like. Okay, so we would say, okay, the prevalence of multimorbidity, if you're going to use these 81 conditions, you can get any prevalence between these 2 lines. If you go back to the systematic review and say, well, okay, this is the whole population, all ages, what prevalence of multimorbidity did whole population studies observe? Then you get 5 studies in the middle. And they all sit in the middle. And if you look at the 40 row, then the upper dot is our original paper in the Lancet, where we observed about 25% in multimorbidity. And that's quite a lot less than if we'd chosen a different set of 40 conditions. But of course, our conditions were also modified. So we said you had to have active asthma, whereas this is measuring asthma ever, for example. There's a lot going on here that isn't visible just in the number of conditions. Most studies in the literature are only in adults. So if you restrict it to adults, you get slightly different lines because prevalence, maximum and minimum prevalence multimorbidity is higher in adults. But actually, most studies do lie between the lines. But you can get any result you want for prevalence just by changing what you include. If you use always include, you get quite a low prevalence, and that's partly because there's no depression in it. And depression is very common, and it's very commonly comorbid with other things. And so that would make me say, I'd say it's the wisdom of crowds. The crowd wasn't an idiot with that one. You should always use the bigger list. If you use usually include, then you get a higher prevalence of multimorbidity, but it is quite a bit below the blue line. But that's partly to do with different decisions on lumping and splitting. So some of what's in usually include is a lumped condition, and some of what's in the blue line is it's split out. And so you could argue you're double counting in the blue line, or you're undercounting in the usually include dot. What's the truth? Well, it kind of depends what you think is right. Okay, so one quick thing about complex multimorbidity. So this is showing by age on the x-axis, the percentage of people with multimorbidity, defined in 4 ways. And then the separate lines are deprivation. So the purple line at the bottom of every graph is the most affluent, and the blue line at the top of each graph is the most deprived. And so what you see is that multimorbidity, however you measure it, gets more common with age, and you'll see it's socially patterned. The poor have more multimorbidity than the affluent. So top left is 2+ conditions, and so that's kind of normal multimorbidity. If you move over to the top right, then that's 3 or more conditions, and so you get lower prevalence, but the shape is very, very similar, and the kind of social gradient's very similar. If you move to 3 or more conditions from 3 or more body systems, then again, the prevalence is lower, but the shape and everything else is not that different. If you look at multimorbidity in a very different way, which is do you have physical mental multimorbidity, you get a very different shape, and you also get a much bigger social gradient. And so what's right for complex multimorbidity? Well, it would kind of depend on what your purpose is. I mean, again, and I'll keep saying it, what's right depends on what you want to do. So what does it all mean? And so, I mean, those of you who have met me before know I'm not exactly, I'm not known for being an optimist or a ray of sunshine. So, what does it all mean? Well, we're all in trouble because it's all really complicated, and we can all end up doing some very, very different things. I mean, I'm just showing you prevalence. Prevalence is the easy thing to do, but it's still really, really complicated. I mean, I don't think there's any definitively correct way to measure multiple long-term conditions, and I don't think in my lifetime we're going to be in a situation where we can say this is definitely how you should do it. What we're talking about is all of life, and all of life is too complex to really make simple. But there are a number of decisions that we all have to make, which are the same decisions. Which condition, how many conditions, which conditions, how are you going to lump them, how are you going to split them? What we can do about code lists, and that's definitely improvable, and doing stuff together would improve it. And just be aware that the same data may not be the same. Just because it's GP data doesn't mean it's the same. It's been generated in a different way, in a different context, and it's probably the same enough, but you might, you do want to know where it's different. And of course, for the purposes of replication validation, having data that isn't quite the same, but is very similar, is actually quite good for validation, because if models are not robust to small amounts of difference, they're probably not real. So what can we do, though? I'm trying to be more positive. I mean, we can improve replication comparability. And so when you're doing this, you need to tell everybody which conditions you're including. And I think we should all be justifying the choice of every condition. And we should be explicit about our decisions about whether to lump or to split. So we have chosen chronic liver disease as a category because we have chosen these causes of chronic liver disease and defined them as being on their own or complicated by cirrhosis, portal hypertension, liver failure, and varices, or whatever decision you make. but that should be explicit and should be an appendix table that is completely clear. I mean, I think we should be using existing code lists where possible, but we're always going to modify them, because you look at someone else's code list and you don't like it at the margins, or it's not suitable for your purpose. And so every one of us should publish our code list and justify. I think if you are publishing, you might, certainly for prevalence, I would suggest that we all publish prevalence based on always or usually. That set of conditions, as far as you can match it. And everyone needs to report age, sex, categorized prevalence, because that's the only way to directly compare prevalence in different studies. And so you might report your own set of conditions, prevalence, but I think we should all be reporting consistently prevalence in a way that makes it comparable as well, because that also informs what your bespoke prevalence is as well. And we all need to be agreeing what core condition sets are in code lists to facilitate replication. And then doing our own thing. So, what is the shared core, and then what's going to be different. And so, I mean, I said I had more. Well, I mean, there's a set of problems we all share. Really, have any answers? But we can do things better, and it would be interesting to explore how that might work. Thank you.